Our journey into the world of artificial intelligence begins in the mid-20th century, rooted in the curiosity and visionary ideas of pioneers who dreamed of intelligent machines. In the summer of 1956, a pivotal moment in the history of technology took place. John McCarthy, a visionary computer scientist, coined the term artificial intelligence during the Dartmouth Summer Research Project. This groundbreaking event brought together some of the brightest minds of the era. Before all this, another pioneer, the legendary Alan Turing, was asking himself if machines could think and solve problems as humans do. All these innovative ideas set the foundational goals for what would become the field of AI. Their collaborative efforts laid the groundwork for the advancements we see today, shaping the future of intelligent machines and transforming the world as we know it. The early milestones of AI were marked by simple but effective programs like ELIZA and chess-playing computers. ELIZA, developed in the 1960s, was one of the first programs to simulate human conversation, showcasing the potential of natural language processing. Meanwhile, chess-playing computers, such as IBM's Deep Blue, demonstrated that machines could perform tasks traditionally considered requiring human intelligence. These early innovations laid the basis for future advancements, proving that computers could not only follow instructions, but also engage in complex problem-solving and strategic thinking. The achievements of these pioneering programs were crucial in shaping the trajectory of artificial intelligence research and development. AI faced periods of reduced interest and funding, known as the AI winters, due to unmet expectations and technological limitations. First AI winter, mid-1970s. During the 1960s, excitement about AI grew as researchers made bold claims about machines that would soon match or exceed human intelligence. However, these claims were based on early successes in limited or simplified environments. These obstacles were basically computational limitations. The hardware of the time was simply not powerful enough to support the ambitious projects envisioned. Lack of advanced algorithms. Early AI algorithms struggled with understanding natural language and could not generalize from one task to another. Knowledge bottlenecks. AI systems required vast amounts of knowledge about the world to make sense of complex contexts, something that was difficult to encode manually at the time. Second AI winter, late 1980s, early 1990s. Similar issues influenced the second AI winter. Overpromising and under-delivering. 1. Expert systems limitations. In the 1980s, expert systems, which are AI programs that emulate the decision-making abilities of a human expert, became popular. They were initially successful in specific domains like medical diagnosis and geological exploration. However, they were expensive to develop, maintain, and update. They also lacked the ability to generalize beyond their narrow domains of expertise. 2. Collapse of the Lisp machine market. AI research had heavily invested in specialized hardware like Lisp machines. When general-purpose computers became powerful enough to run AI applications, the market for these expensive, specialized machines collapsed. Chapter 6. Go Big or Go Home, Texas. Dive into AI. We've got this. $100 billion AI initiative in Texas. As AI continues to evolve, it empowers us to achieve more with less effort, promising a future where technology and human creativity are intertwined. The $100 billion AI initiative involving the construction of data centers and expansion of AI infrastructure will require a diverse range of careers and professions, including data center technicians and engineers, professionals skilled in maintaining and optimizing the physical infrastructure of data centers, including servers, networking, and cooling systems, software developers and AI specialists, experts in artificial intelligence, machine learning, and software development to innovate and manage AI applications, electrical and mechanical engineers, engineers who design and maintain the power and mechanical systems crucial for the high-demand environment of data centers, cybersecurity analysts, security professionals to protect data centers from cyber threats and ensure compliance with data protection regulations, project managers and construction specialists, experienced individuals to oversee the construction of data centers and ensure projects are completed on time and within budget, operations, staff, personnel to manage the day-to-day operations, logistics, and administration of data centers. Research scientists, researchers to drive innovation in AI technologies and applications, particularly those focusing on scalable solutions. Network engineers, experts in network design and maintenance to ensure robust connectivity and performance within data centers. Legal and regulatory advisors, specialists in legal and regulatory aspects to navigate the complexities of international tech development and intellectual property. Environmental consultants, advisors to help design and implement sustainable practices within the construction and operation of data centers, focusing on minimizing environmental impact. These roles are critical in supporting the expansive infrastructure required to advance AI technology, ensuring efficient, secure, and sustainable operation of data centers. In an era increasingly dominated by AI and automation, the roles of secretaries, assistants, and office personnel are transforming. We will need enhanced administrative assistance. Traditional tasks like scheduling and correspondence management are increasingly automated. Future administrative assistants might act more as project managers or team coordinators, overseeing automated systems and ensuring that AI-driven tasks align with human needs. Tech-savvy receptionists. With AI handling basic inquiries and visitor management, receptionists might take on roles that require a higher level of guest interaction or troubleshooting more complex issues that AI cannot resolve, such as handling special accommodations or sensitive situations. Strategic HR assistants. While AI can screen resumes and schedule interviews, HR assistants will need to focus on enhancing employee relations, handling sensitive information, and crafting organizational culture, which requires a deep understanding of human behavior that AI cannot replicate. Financial coordinators. AI can handle data entry and basic bookkeeping, but financial coordinators will need to interpret AI-generated reports, provide strategic financial advice, and oversee complex financial planning. But what skills will they require? Technical proficiency. Understanding and managing AI tools and software will be crucial. Skills in data analytics, AI software management, and basic coding might become fundamental. Critical thinking and decision-making. As AI takes over routine tasks, these professionals will need to focus on strategy and decision-making, interpreting the output of AI systems, and making judgment calls on non-standardized tasks. Interpersonal and communication skills. Emotional intelligence will be more valuable than ever. The ability to manage relationships, understand complex human emotions, and communicate effectively in a tech-driven environment will be essential. Adaptability and continuous learning. The landscape of technology changes rapidly, requiring constant learning and adaptation. Professionals will need to stay updated on the latest technologies and continually adapt their skills. Ethical and cultural understanding. As AI impacts more aspects of the workplace, understanding the ethical implications and maintaining the organizational culture in light of automation will be critical. As AI continues to evolve, it empowers us all to achieve more with less effort, promising a future where technology and human creativity are intertwined. These future-oriented roles and skills highlight a shift from traditional task execution to more strategic, analytical, and interpersonal functions. Emphasizing continual education and adaptability in the face of advancing technology will be key for professionals in these evolving roles. As we reach the end of this journey, let's pause and think about the incredible future ahead of us. You've heard about AI and how it's already transforming our lives from healthcare to transportation, but soon we'll likely reach the next level, AGI, or Artificial General Intelligence, a machine capable of performing any intellectual task a human can do. A machine that thinks critically, solves problems, and adapts to new situations. That's the promise of AGI. It could help us unlock cures for diseases like cancer, analyze vast amounts of data, find patterns we can't see, and develop treatments faster than we imagined. AGI can tackle global challenges, climate change, food scarcity, inequality, and find solutions to make the world better for everyone. Here's the most exciting part. We are the pioneers of this future. The choices we make today, how we embrace AI and adapt to change, will shape the world we leave behind. We have the chance to be the generation that leads the way. The future isn't a distant dream, it's here, right now. It's up to us to forge it. Together, let's create a future of peace and progress for our planet. The path is ours to choose. Thomas Edison once said, "The value of an idea lies in the using of it." This reflects the notion that inventions and technologies are not inherently good or bad. It is how we choose to utilize them that ultimately determines their impact on the world. Whether they lead to progress or harm depends entirely on our decisions and actions. Thank you for listening.